This video is for topic 5.7, Introduction to Reaction Mechanisms. The objective for this topic is to identify the components of a reaction mechanism. First, let's talk about what mechanisms are. Mechanisms show possible pathways for a reaction to take place at the particle level. So what we're showing are the different elementary reactions that could possibly happen for an overall reaction to take place. These are not facts, they're just good guesses for what's going to happen. If you get a reaction cold enough, you can see some of the different elementary reactions that happen, but this is not a common thing. That is a recent development in chemistry, is that scientists can get a reaction cold enough so that they can actually see what's going on and can monitor the different steps of a reaction. So as a result, we can have multiple mechanisms that explain one reaction. So what we're going to be looking at is whether or not a reaction mechanism is valid. So mechanisms are going to relate to the rate of the reaction. The products of a reaction can never be produced at a rate faster than the rate of the slowest step. We call this the rate determining step. So the slowest part of the reaction is what's going to determine the overall rate, because the slow step is going to hold everything else up. Nothing can happen faster than the slow step can happen. So that slow step we call rate determining. The rate of the overall reaction is then limited by the combination of all the elementary steps through the slowest step in the mechanism. Intermediates are produced by elementary reactions and then consumed in others. So these are the species that you'll see in the elementary reactions, but you won't ever see them in the overall reaction equation. The detection of intermediates by different experimental methods is what can help better support a mechanism. So if you can detect an intermediate, you can use that as part of your evidence for why a mechanism could be valid. But an intermediate is something that's never going to show up in the overall reaction equation. So you'll see them produced, so there'll be a product in one elementary reaction, and then they're going to be a reactant in another elementary reaction. So they'll ultimately be consumed.